Hello, this is my CE570 Project Week 9 by JaredKosaki. So for this week's project, I have to define a symmetric Cauchy stress tensor field. I also have to compute the body force density needed for equilibrium, and I also have to verify the total force on one part of my 3D body. So the shape I used was a 3D pen, and here on the right-hand side, this shows what it would look like if I were to output in MATLAB. So here, this shows my parameterization part 1. So this is the part of the code for a short cylinder for the head of the 3D pen. So pretty much the code is the same from previous weeks, but for this week's project, I had to add in the code for the body.b4, which is for the body force. And here in this slide, it's just the parameterization part 2. So this is the part of the code for the skinny cylinder part of the 3D pen. So pretty much the code, the process of this code is the same as from the last part. And here, this is my parameterization part 3. So this is the part of the code for the cone for the 3 pen tip. So the process of this code would be the same as from the last two parts. And here for the stress field, I have to define the stress field in terms of x1, x2, and x3. And here is where I'm at scale, and here is where I'm able to adjust the magnified vector plot as a displacement. And here, this shows my output. So this is what it looked like if I were to run in MATLAB. So here, this is showing my stress field. And for the symmetric Cauchy stress tensor field, so to define the stress field, I had to take the undeformed configuration. So that would mean that x will equal to the undeformed z, and also the deformation gradient will equal to the identity. And then also when defining the Cauchy stress tensor field, it needs to be symmetric. And I also found out that it is also a linear stress field, and it is in terms of x1, x2, and x3. And then next, I had to define my body parameterizations for my 3 parts of my 3D body. So for the short cylinder, for the skinny cylinder, and for the cone. And then next, I have to replace x1, x2, and x3 with the corresponding parameterizations to get the stress field that is defined using the parameterization of the 3 parts. So here is my stress tensor field for body parts 1 and 2, and here is my stress tensor field for body part 3. And here for the body force density needed for equilibrium. So the body force will equal to the negative divergence of S. And then I got that my divergence of S turned out to be a constant field since it is a linear field. So in the end, I got my body force to equal to -4 E1, E2, E3. And then next, since I have a constant field, it would just be -4, which is independent of the parameterization I have for each part. So for body parts 1 and 2, it will be -4, -4, -4. And for body part 3, it would also be -4, -4, -4. And lastly, for the total force acting on the surface, so I chose to find the total force acting on the circular top surface of the short cylinder of the 3D pen. So like first, the total body force acting on the surface that I computed for MATLAB was -150.79 E1 plus E2 plus E3 units. And then here, to show it by hand, I had to take, so in order to compute the total force due to the body forces on the surface, I would have to take the triple integral on the surface, and then I would then get -150.79 E1 plus E2 plus E3 units. So here I can see that I got the same as from what I got from MATLAB, so I know that this is correct. So this is my presentation, and thank you for listening.